In this video, I will show you how to write and graph the standard form equation of a hyperbola even when the center is not 0, 0. So a hyperbola has two branches. Each branch has a vertex, the point here and the point here. The center of the hyperbola is right in the middle between those two vertices. There are co vertices which are not on the hyperbola, which we'll talk about later. A hyperbola has asymptotes, where the branches are approaching those asymptotes on either end. Each branch has a focus in the interior, a single point that the branch is sort of wrapped around. Now, looking at the standard form equation of a hyperbola, you have to pay attention to whether or not the hyperbola is horizontal, or you could say the transverse axis is horizontal, where the segment connecting the vertices, that's the transverse axis. So when I talk about a horizontal hyperbola, you can think about the transverse axis being horizontal. Anyway, if the hyperbola is horizontal like this one, the x term will be first. If the hyperbola is vertical like this one, then the y term will be first. Notice that we always have this fraction minus a fraction equals 1. There's always a positive term and a negative term. The denominator of the positive term is always considered to be a squared, and that's always going to be the distance from the center to a vertex. This is always going to be a. Okay, regardless of whether the hyperbola is horizontal or vertical. Center to a vertex, that is a. There's a value called b that's going to be from the center to a co-vertex. All right, from the center to a co-vertex, that's b. There's a value called c, which is the distance from the center to a focus. Okay, center to a focus, that is C. Whoops, I'm going the wrong way. From the center to a focus is C. Of course, the center itself is h comma k. It's the opposite of this and the opposite of this. Please keep in mind that for hyperbolas, the formula relating a, b, and c is c squared is equal to a squared plus b squared. For ellipses, it was always minus. So speaking of ellipses, for ellipses, the a squared was always the bigger denominator. That's not going to be true for hyperbolas. It doesn't matter which one is bigger. A squared is always going to be first. It's always going to be the denominator of the positive term. Okay, enough background information. You will understand more if we just dive in. For number 1, we are to write the standard equation for the hyperbola, and we're given some information. In this case, there's a horizontal transverse axis. The center is -1, 2, and we're given the a value and the b value. Whenever they give you some information like this, you should always draw a sketch. All right, let's start with the fact that the center is -1, 2. And there's a horizontal transverse axis. That will get us halfway through the equation right there. If we have a horizontal transverse axis, in other words, a horizontal hyperbola, right away that means the x term is going to be first. So you know we're going to have a fraction minus another fraction is equal to 1. But if it's horizontal, then the numerator is going to involve x. So I'm going to have an x right here. Because of this -1, x coordinate of the center, this will be x plus 1 squared. I'm basically doing the opposite of this. Because of the 2 right here, I know I'm going to have y minus 2 squared. So all we need is a squared and b squared. We know that the a squared goes first. So since a is 4, this will be 16. And since b is 6, this will be 36. So I just said to do a sketch, but we didn't actually need to do a sketch for this problem. All the information was right there. Looking at part B here, again, we probably won't need a sketch for this particular one. So we have a vertical transverse axis. That means since it's a vertical hyperbola, the y term is going to be first. So I know I'm going to have y in the parentheses. And the y coordinate of the center is 4. So I'm going to have y minus 4 squared. And so that should be first. And then in the next numerator, I will have x minus 3 squared because of the positive 3x coordinate. I'm doing the opposite of that. We know it's always equal to 1. The first denominator, the positive denominator, is always a squared. So since a is 5, this will be 25. The second denominator is going to be b squared. They didn't give us b this time. They gave us c. But that's okay. That'll just take a couple extra steps. We know that c squared is equal to a squared plus b squared for hyperbolas. So since c is 7, c squared is 49, a squared is 25. Okay, so plus b squared. So we just need to subtract 25 from both sides. So this is going to be 24 is equal to b squared. We're not going to take the square root because we actually want b squared. So this denominator will be 24, and this is the standard form equation of the hyperbola described. Okay, for example 2, they gave us an entire graph. This is just a wealth of information, so this should be pretty easy. At a glance, we see that it is horizontal. So right away, that lets us know that the numerator, the first numerator, is going to involve x. And the second numerator is going to involve the y. I don't know why I put a fraction over here at the end when we know this is going to equal 1. So the center. You see the center right here is 1, 0. So because of the 1, I'm going to have x minus 1 right here. Because of the 0, it would be like y minus 0 or y plus 0. So obviously, I'm not going to put the 0. So this will become y squared. So all we need is the a value, well, a squared and b squared for the denominators. Remember that the a value is just the distance from the center to a vertex. So this is 4. So we see that a is 4. So that means, of course, a squared is 16. So the first denominator is going to be 16. The b value is the distance from the center to a co-vertex, which is not an actual point on the hyperbola, but it would be the side of this rectangle. So I can see that the b value is 2, so therefore b squared is 4. So that's going to be this denominator. So that's it. Here's the standard form equation of this hyperbola. Okay, what about b? This one's vertical, so I know that I'm going to have y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Okay, it's vertical, so I know the y term is going to be first. Check out the center. All right, here's the center at 0, -1. So the 0 is my h, and the -1 is my k. All right, so the -1 is going to go right here and become +1. Okay, just the opposite of this y value goes with the y part of the equation. And this 0, the x coordinate, goes here in the x part of the equation. But since it's just a 0, I'm not going to put it. So it's just going to be x squared. So now all I need is a squared and b squared. Well, a is the distance from the center to a vertex. So a is 4, which means that a squared is 16. So this will be 16. B is the distance from the center to a co-vertex. All right, a co-vertex is not an actual point on the hyperbola, but I can locate it by looking at the side of this rectangle that's been drawn. So I see that B is 3, so that means B squared is 9. Okay. Remember that a squared is always first for a hyperbola. It's the denominator of the positive term. B squared is always second, the denominator of the negative term. Anyway, that's it for part B. All right, for example 3, we need to graph this hyperbola and label all the stuff. At a glance, we know what the center is going to be. It's going to be the opposite of this and the opposite of this. Be careful of the order. The x-coordinate has to come from the x part of the graph, so that's going to be 3. And the y-coordinate is going to be the opposite of the y part of the equation, so that's going to be a 2. So the center is 3, 2. I think it would be good to go ahead and just graph that right now. Okay, so here's the center right here at 3, 2. Now let's find the vertices by looking at the by finding the a value. So we know that this first denominator is going to be a squared. So that means a is 5. This will lead us to the vertices because I'm going to do plus and minus 5 from the center. Now notice that this 25 is the denominator of the y term. So I will do my plus and minus 5 in the y direction. So starting at the center, I will go up 5. All right, there's a vertex. And I will go down 5. Here's a vertex. So right away, I know that the vertices are 3, -3, and 3, 7. Okay, so those are my vertices. All right, let's find the co-vertices now. So we know that the second denominator, the denominator of the negative term, is always going to be b squared. So if b squared is 16, then b is 4. Notice that the 16 is the denominator of the x term. So I will do plus and minus 4 in the x direction. So looking at the center, if I go 4 to the right and 4 to the left, these are my co-vertices. So my co-vertices are -1, 2, and 7, 2. Okay, this is enough information for us to go ahead and draw the hyperbola right now. Let me zoom out a little bit. Because we have the vertices and the co-vertices. So it's time to go ahead and draw the rectangle that contains the vertices and co-vertices. This rectangle will show us where the asymptotes go. All right, so just draw a rectangle through the vertices and the co-vertices as a dotted line. Okay, now, what was this? 5/4. So the asymptotes will go through the diagonals of this rectangle. So I'm going to have an asymptote that goes like this. And I'll have an asymptote that goes like this. Okay, with those asymptotes in place, we can actually go ahead and graph the branches. Remember, this is a vertex and this is a vertex. So the branches are here, and of course they will approach the asymptotes. Okay, so our graph is done. We need to find the C value so we can fill in the foci. For hyperbolas, C squared is equal to A squared plus B squared. So that means C squared will equal 25 plus 16. So C squared is equal to 41. So C is equal to the square root of 41. Now for graphing purposes, it would be useful to know that the square root of 41 is approximately 6.4. So let's go ahead and graph that real quick. So 6.4 from the center will be the location of a focus. So 2, 4, 6.4 would be about here. So there's a focus, and we'll have another focus right about here. Now when we label these foci, we cannot use that decimal approximation. Now the x value of this focus is very clear because this focus is right on the line, same as the center, same as the vertex. So the x-coordinate of this point is definitely 3. Okay, note that we don't have to guess about that. Same thing with this. This is definitely 3. So we're going to have 3 comma something. The y value takes a little bit more thought. The best thing to do is to start with the y value of the center. The center has a y value of 2. So we're starting at 2. And we're going up a certain amount, so we're adding something. Now the thing that we're adding is the C value, all right? That's the distance from the center to the focus. So we're doing 2 plus the C value. The C value, remember, was radical 41, and that's the way we have to write it. So 2 plus radical 41 is the y-coordinate of this focus. So we have 3 comma 2 plus radical 41. Okay, similarly for the lower focus, we will have 2 minus radical 41 because we're starting from a y value of 2 and we're going down radical 41. We're subtracting. Okay, so 3 comma 2 minus radical 41. Let's go ahead and get the E value out of the way. The eccentricity is always C over A. So in this case, that's radical 41 over 5. All right, the last thing we need to do is state the asymptotes, the equation of the asymptotes. So look, you can use the following model for the equation of the asymptotes of any hyperbola. This is really just point slope form for the equation of a line, but I'm going to use the center. Anyway, you can always go y minus k is equal to plus or minus m times x minus h. All right? This is just point slope form because you can put in a point for h and k, and m is the slope. I'm using h and k because those are the coordinates of the center. So just make sure you use the coordinates of the center. So in this case, the center has coordinates 3, 2. Okay, so this is my h and my k, 3, 2. So when I write the equation of the asymptotes, I'm going to start with this 2, the y coordinate, and I'm going to put y minus 2. Now I have to do plus or minus. Now I need the slope. Look at this diagonal. I need to know the slope. I'm talking about the rise and the run. So let's see. This is up 5 over 4. So the slope is 5 over 4, rise over run. Now I need x minus h. The h value is this 3. The x coordinate goes with the x part of the equation, of course. So I will just put x minus 3. And that's it. This represents both asymptotes because of the plus or minus. The positive 5 over 4 is the upward sloping asymptote, and the negative 5 over 4 is the downward sloping asymptote. And that's it for example 3, part A. All right, part B. All right, we're still on example 3, but we're on part B. So the center, though, opposite of this, opposite of that, we know that the center will be -2, +1. Let's go ahead and graph that. -2, +1, boom, there's the center. Let's find the vertices by knowing the a value. The first denominator, the positive denominator, is always a squared. That means a is 5. This 25 is the denominator of the x term. So I will do plus and minus 5 in the x direction. So if I come down here, I will go 5 to the left, vertex. I will go 5 to the right, vertex. So this vertex is -7, 1. And this vertex is 3, 1. Okay, now let's find the co-vertices by looking at b squared. The second denominator, the negative term denominator, is always b squared. So the b value is going to be 2. Notice that this 4 is the denominator of the y term. So I will do plus and minus 2 in the y direction. So my co-vertices will be here and here. So I have a co-vertex at -2, -1. And I have another co-vertex at -2, 3. Now that I have the vertices and co-vertices, I'd like to go ahead and sketch the hyperbola. But first I'm going to need the asymptotes. So let's go ahead and draw the rectangle that passes through the vertices and co-vertices. So draw this rectangle as a dotted line. Because that shows you what the asymptotes are going to be. Because the asymptotes should go through the diagonals of this rectangle. Okay, so with the asymptotes in place, and remembering that these red dots here are the vertices, then I know that the branches should be over here approaching the asymptotes like this. Okay, so there is my hyperbola. Let's go ahead and find the foci, which should be floating in the interior of these branches. We're going to need the c value for that. For hyperbolas, we know that c squared is equal to a squared plus b squared. So that means c squared is equal to 25 plus 4. So c squared is equal to 29. So c is equal to the square root of 29. For graphing purposes, it will be useful to know that the c value is approximately 5.4. Okay, so if I go 5.4 to the left and right of the center, that will be a focus. Okay, so this is 5, so 5.4 is just going to be a little ways over. So there's a focus. And whoops, here's a focus. Now when I label these, I can't use the 5.4. I have to use the radical 29. Understand that the y value of this point, for example, will definitely be 1. It's sitting right at a y value of 1. So I don't need to worry about that. It's just the x value that's a little weird. For the x value, start with the center. The center has an x value of -2. So I'm going to start with -2. Now I'm going to the right by a value of c. Because I'm going to the right, I'm going to add. And c was radical 29. So this is the expression for the x coordinate of this point. -2 plus radical 29. Okay, so I will have one focus at -2 plus radical 29, comma 1. Similarly, the other focus will be -2 minus radical 29, comma 1. Okay, it's still at a y value of 1, but it's starting at -2. We're going to the left by radical 29, so we're subtracting radical 29. Okay, now that we have the c value, let's state the eccentricity. E is always c over a. So this will be radical 29 over 5. All right, finally, let's state the equation of the asymptotes. So look, you can always use point slope form to find both equations of the asymptotes. So what I mean is we can just do y minus k is equal to plus or minus m times x minus h. This is a model for the asymptotes of any hyperbola. Just understand that h and k is still the center, like it always is in these formulas. M represents the slope of the asymptote. So because of that, so remembering that the center here is -2, comma 1. All right, this is my h and my k. Substituting those in, I'm going to have, let's see, y minus 1 as I do the opposite of this. So I'll have y minus 1 equals plus or minus. Now here comes the slope. Look at this diagonal. So from this point at the center to this point at the corner, what is the rise and the run? Well, remember, it was the b value and then the a value. This is up 2 over 5. So the slope is 2/5. So I'm going to put plus or minus 2/5. And then I will have x, and here comes the h value. So I'm going to put x plus 2 as I do the opposite of this. So this equation really represents both asymptotes because of the plus or minus. Positive 2/5, that's the asymptote with the positive slope. Negative 2/5 is the downward sloping asymptote. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.